Hey guys, welcome back to the F15 XXL from Skymaster Jets. Loving this plane. It is beautiful. I feel like it is the pinnacle of Skymaster up to this point. They've done amazing things with this aircraft. We're diving back into video number 3, continuing with the tail section. So let's dive back in. Previous video, we got our tanks done, we've got the gear back installed, we got our vertical stabs on, and yes, for those really observant folks, the P is wrong. That should be an F. We will change that. Everywhere else is fine, but not a big deal. So vertical stabs are done. We're going to continue on with our horizontal stabs, which we covered a little bit in the previous video. Get our afterburners installed. Turkey feathers, those were painted black in the last video, so ready for the afterburner lights to get installed on that. Now, an important thing with dealing with this tail section, especially the horizontal stabilizers, so there are some key critical things that I'm going to share with you. This is very common with every Skymaster plane, so if you're doing an F18, an F14, an F15, any of the Skymaster planes that use this system, it's very important that you do things the way I'm showing you because it ensures longevity, it ensures replaceability of components, so we'll get more into that, but pay attention to that stuff. All right, so working on the horizontal stabilizers, made the servo arm. So this is the normal setup for Skymaster. Now, I don't know yet if this is the right distance for the servo arm, so we'll get there, but I'll give you guys the measurements for this. So I ended up drilling out the inner hole with a 3mm drill bit. So that, just for reference, is about 14mm center to center. Now, it's quite important to use the stock servo arms. You can also use the MKS arms with the brass hub and the carbon plate. That works as well too. So we drilled this out with a 3mm, cut the end off obviously, and then you have to use a taper bit and get that back side of the servo arm tapered. And the reason for that is your head of your screw that needs to be installed needs to sit flush with the back. So you don't want to have any part of that screw sticking out because that's going to rub on the cover plate and the fuselage. This is all very tight stuff. So this is the setup here. Put red Loctite on the back side of that so it gets nice and held in place. And then what we do is we take our bearings and get that setup done. Now the kit comes with 4 bearings per side. Usually 3 is fine, but the 4 is there. So what I'll do is put a spacer, a bearing, a spacer, a washer, a bearing, a washer, a bearing, and then so we'll get that all installed and then use the lock nut and get a nice bearing system installed here. Now that bearing is what slides or interacts with our receiver portion. This receiver portion mounts in the horizontal stab surface. So what I'll do now is I'm going to get our servo plugged in, centered, the output shaft, as we talked in the previous video, the output shaft goes towards the rear of the aircraft, and then the servo arm is going to go forward towards the forward portion of the aircraft, and that should line everything up nicely. So number 1, I'm going to get that servo centered. Number 2, we're going to get our extension installed and get the servo installed in the aircraft. All right, so some initial setup guidance here. So we've got the servo screwed in place, which is good. The arm is just temporarily installed. One of the pinch bolts is installed. We've got the receiver portion screwed into the horizontal stabilizer. And the point of doing all this is to see how things work out. So with that arm length now, I think we're not, so just based on my previous mark, I think that is the front of the channel. And this is our current bearing location. So the further forward you can get that bearing location, the better, because what happens is as this moves, the bearings slide back in the receiver. So right now, if we go sort of neutral like that, the limit of our travel is there, which is probably enough, but we want to have that maximized as much as possible. So the point of doing all these marks is now we can pull this off and we can see where the bearings sit in relation to the actual channel in the receiver portion, and then we can maximize that. So this was sort of a sacrificial servo arm. to get to our next step. So I'm going to pull this back out. And the other thing is, I think we're probably going to try and get 4 bearings on there. The spacing on this is really nice. On previous Skymaster aircrafts, these have been a little bit tighter to the fuselage, but this allows nice movement on that servo, which is great. So, all right, so here's a new arm. So we'll get our servo center installed like that. And so from here, this is our current bearing pivot point or bearing location right there, which lines up, of course, with our innermost hole. So what I'll end up doing here, I think, is this is our end of our channel. So what I'll end up doing is drilling out the second hole, which will allow enough space for our bearings to sit in there. But because of that, we'll also get a little bit more travel on our horizontal stab. So I'm going to get another one of these arms made up, and we will get that installed. And the measurement to that second hole, just so you've got it, is center to center, 20 millimeters on that second hole that we'll end up using. All right, guys, so we got our elevator servo all sorted out here. So ended up using some spacers on the back side. So these spacers are plywood. And the point of the spacers is we have some room to bring that servo arm out. Now, a couple things that does. Number one, it brings the face of the servo flush with a little indent here. The other thing it's going to do is it's going to space out the servo arm, so the servo arm's not touching the skin of the aircraft. Because we've got that extra spacing with these horizontal stabs, it just makes more sense to space that servo out. So depending on the servo you're using, that may change. We went with a 4 bearing setup because there's more contact area needed for the receiver portion, and the servo arm right now is just temporarily held in place with that 1 screw. So now we can put the servo in for the last time, and we don't want to put that servo arm on yet because we have to get our cover sorted out. And then once the servo's in place, we can test the movement and see how everything works out like we did previously. So much better on the setup with the tail here, so we're roughly neutral there, and got tons of movement, probably 3.5 inches at the leading edge in each direction. So that's going to be wonderful. Our spacing here is also good, so if you look in between there, you can see our servo arm is spaced out a little bit from the plate that's going to cover that, and we still have some nice space between the actual surface. So good job, Skymaster. You guys did a great job on this setup. Best one yet that I've seen. And that's wonderful. So now we're going to get the other servo installed and get that one set up. So here's our final setup. Just before I put it in, I still need to round these guys off a little bit. But we've got our plywood just glued in place. We've already pre-treated the holes in the fuselage. Our servo arm set up here. Yes, the servo arm's not fastened because it needs to come back off, as you'll see, but that one is ready to go in. All right, so now we're going to work on our cover plates here. So we've taken the stab off, obviously, and next thing we're going to do is get the servo arm centered so you know where it needs to go back on. So we're roughly in the center there, and now we can pull this servo arm off. There we go. So next thing I'll do is get this guy lined up and mark our center. So we're just going to do a big hole here. So we'll get it tucked up to the back end like that. And then this way like that. So now we know where the servo output shaft center is, and we basically do a hole big enough for the back side of the servo arm to fit through and move sufficiently. All right, here's a shot of one of our completed elevator arms. So we've got our cover plate installed. Had to do some sanding to shape this properly. So did my hole first, and then did the sanding around the perimeter. Drilled some holes, used the countersunk screws, or made a countersink and then used the stock Skymaster screws. So that is perfect. So we'll do the exact same thing on the other side. Nice thing with all this spacing the way it is you can actually get this arm on and off quite easily if needed. On some previous Skymasters where that servo was inset more, getting at those pinch screws is quite difficult. So I like the setup. Like I've mentioned, it's great. All right, and our other side is now set up. So we're gonna move on to our turkey feathers / tail cone setups. We need to get those sorted out and our afterburner lights mounted so we can start running all the wires forward. Having the wires go forward is kind of one of those critical things. You don't want to start plugging everything up in the back end and then having to deal with running wires, so not fun. So we'll get the afterburner lights set up next. So I've got our tail cones here laid out just like they go in the airplane. So we've got our left one and our right one. So when you look at these pipes, you'll notice the angle on the pipes. So this is pretty common for this type of setup. So this is the left pipe. So the pipe comes back and then angles out towards the, away from the center line of the aircraft. So to give you a better perspective, this is the pipe, the left pipe, looking at it from the back, obviously. That L in there is marked from me. That's not from the factory. So when you look at the aircraft, that pipe comes back and then angles this way. So what's the point of that angle? Well, the point of the angle is if you took a center line, an arrow shaft, and had it perfectly centered in that angled part of the pipe, it would end up pointing to the CG location on the aircraft. Now, not just the CG location front to back, but also the CG location side to side. So here's our CG location. We'll just say it's on this wing tube. If you took a look at that pipe, like I said, ran a center line or a straight line, it's probably going to end up right here in this location right there. And that is the same scenario with the F15 that we have up there that is now sold, but it's got the rear mounted engines. So when I built that, on a rear mounted plane like that with the engines, it's extremely important that those turbines running a center line end up right at the CG location, front to back, side to side, which of course is done. So we've got our afterburner lights placed in there. This one wire is just sitting on the side. The other wire is going through the big circle. And the wires I'm not dealing with right now. We're going to put a connector at the fuselage as well. So these are still going to be removable for any servicing. But we've got this laid out where it needs to sit. We have a bit of variation there. And we'll just glue the afterburner light on with some aero epoxy. So just go around and put a couple dollops of aero epoxy all the way around that whole setup here. Do the same thing on both sides. And then once we're happy with it and it's all fastened down, we'll just use some goop and install the diffuser onto the LED setup. So turkey feathers, tail cones here. We've got the afterburner lights glued in place with aero epoxy. And then we've got our diffusers here. What I did is I had that diffuser flipped over, took some goop, put it in there, laid it over top of the lights, put some weight on it. And what happens with the goop is it slowly flows down and now it's curing. So we're just leaving those guys to sit. Next thing we're doing is the tanks. Now I know we're jumping all around a little bit, but I kind of want to get some gluing stuff done before we start moving on to other things. So that's why we're doing this stuff. The tanks, when we glue these together, the high sol that we're using, that needs to sit for like 8 hours, 24 hours kind of thing. So that's why I want to get this stuff glued in place. Stock hardware, big upgrade for Skymaster, but depending on engine size, probably not sufficient. Well, not sufficient for our selection, but depending on what engine you're using, if you're building this plane, they may work. So if you were building this plane with a 190 size engines and below, I would say this stuff would work fine because it's all 6mm Festo tubing. So 6mm tubing is what goes over top of this. If you try and use 8mm tubing, which is high flow tubing, it just slips over top of that and doesn't really seal properly, too loose of a fit. So we will not be using the Skymaster stuff. That's something we don't really use because our engine size isn't appropriate. So when we're doing something like this, we're using a high flow kit. Now these kits should be available on our website soon. I've been waiting to add these to our website, but these are awesome. They come as a full kit just like this. So there's the bung fitting, the through fitting, 8mm Festo tubing size. We've got our vent fitting, which is a 90-degree fitting, which is great. We've got a high flow clunk, little piece of brass tubing for the center, piece of tie wire in there, and some Tygon tubing if that's what you want to use. That's compatible with all this stuff. So great setup, and that's what we'll be using on these tanks. Now don't get me wrong, this is a great setup, huge upgrade for Skymaster tanks. Previously the tanks were coming with like a compression fitting rubber thing which never seals against this, so good upgrade. Now this high flow setup also fits in the stock Skymaster tank, so it's a very tight fit, but it fits in there nicely and works great. So awesome setup. We've got a couple holes in there to hold the aero epoxy, and there's also a little ridge on the fitting there as well too. So great setup that we'll be using for this. So what we do in advance of this is use a step drill bit like this guy, a skinny one. Drill out our holes, and then I treat this hole with thin CA. Use a little bit of kicker on the thin CA. That hardens up all of the fiberglass fibers. Then you can drill out again with your step drill bit, and then use an X-Acto blade and just cut off the sharp edges that are on there. So that's a nice little solution for dealing with the Kevlar fibers because they don't like to drill properly. So those are our saddles ready to be glued. One more step that we'll do when we glue this is I take a Dremel and just do a little bit of roughening around that opening just so our aero epoxy has something to stick to. And I'll show you guys what it looks like drilling these guys out. So first thing we're going to do, we've marked this, and I also mark the direction that the fitting is going to go. So we'll do that until we get sort of a fit like this where we can thread it in. Good. Then we take a little bit of thin CA, soak the fibers, and often as soon as you put that thin CA on there, you'll see those fibers start to smoke, but if you spray a little bit of kicker on there, that works really well. There we go. If the camera's picking that up, it's smoking a little bit as it cures. So now we'll take our step drill bit. Okay, so that's the kind of fit that we're looking for. We want it to be nice and snug and be able to thread that in. The reason we're going this way is that this tank is going to fill from the main fill up, come out the vent, go to the saddle, saddle's going to fill, and then come out the vent and go outside the fuselage. So now that that fits properly, the last little step here is take your X-Acto blade, and we just trim off the face of this. And again, without putting your thin CA on there, this is pretty much impossible because the fibers just stay intact. And I'm not worried about the stuff we're getting inside the tank because we'll rinse the tanks out when we go to pressure check them. There we go. So that is ready to accept our fittings. All right, so we got all of our fittings glued with high sol, and when I did this, I sanded out around each of the openings, took Trusty and just kind of evened out the glue around each fitting. Now I didn't take my finger and tool this or anything, I just used Trusty and just kind of wiggled it around to smooth out the glue. So tanks are done as far as the fittings go. It's actually been about 24 hours, so we're going to spend a little bit of time getting our tanks actually set up now just so they're 100% ready to go. All right, so each of the tanks we will rinse out with some isopropyl alcohol, 99%. So all we do in this case is take basically our bottle here, we dump half the bottle in the tank, shake it around, and then dump the other half in the of the bottle in the tank, shake it around again, and that is basically how we clean out the tanks. So this is an important thing. Even if you got all of the big stuff out of the tanks, When you're installing those fittings, you're definitely going to have some big stuff left or even small dust. So if anything, this is important to do to get rid of all the dust in the tanks. And then if I look in there, I can see all the big chunkies that are floating around in our alcohol. So all of our tanks have been rinsed out. So next thing we're going to do is we're going to get our clunk setups all ready to go. Now in the smaller saddle tanks, we're not going to use a piece of tubing or anything. So we're just going to have the clunk going to the back of the tank, dropping down, floating around. On the larger tanks, so when you get to a longer tank like this, you want to have a mid stiff piece of tubing like that as an example. So what happens is sometimes the tanks will have a baffle in there and you want that rigid piece of tubing to be inside the baffle, or that's what's contacting the baffle, so it doesn't cut the tubing. But in this case with the Skymaster tanks, they just come as a long tank. So we put that rigid piece of tubing in there to keep the clunk from folding back on itself. So basically it stays near the back of the tank, floats up and down, and does its thing. So when we're setting up the clunks, we essentially just avoid the back ½ inch or so of the tank, just so the clunk moves around freely in all orientations. All right, so here's the clunk setup for our main tanks. Good setup. As far as length goes, we are kind of right about there, past the end, so it drops down nicely and travels to all 4 corners of the tank. As far as the tubing that we're using, so we're using St. Gobain Virilison clunk line, which is C210-A. So this is stuff that I get from DreamWorks, but it's a 8mm or large diameter clunk line. Works great. And it also comes in black, I think, as well too, but I usually get the clear stuff. All right, so tank pickups are all completed. Next thing to do is pressure test each of these tanks. So what we do in this case is we take some suitable Tygon that fits over top of the nipples here, and we'll just blow into each one of these tanks, clamp them off with forceps. We'll leave them overnight, and if they're still holding pressure tomorrow, we know they're good. So this is the setup that we use. So we've got some Tygon here that is heated up and pinched off. And then we've got the same Tygon. I like to blow through the vent lines to make sure that you don't get some of the alcohol coming back through the pickup. So all you do in this case is you take a pair of forceps here, or whatever they're called, with the little clippers. And you're going to blow into this with your mouth. You don't want to use air compressor or anything. That's way too much pressure. And you just pinch it off. I like to just put some saliva over the end just to confirm. And we'll do the other one. Now, of course, you could submerge these tanks. If they've got wood strapped to them, I definitely don't like to do that. We've also got time on our side too, so we can leave these overnight. And if we open this up tomorrow morning and they release pressure, we know the tanks are good. Now we're getting back to our fuselage here. So I've just put the tail cones on here just so we could take some pictures for our thumbnails, but basically this also gives us an idea of how we're gonna run these wires. So basically what we wanna do is we wanna have the 2 leads coming from the afterburner lights down to the bottom of the fuselage. So right to the bottom of the tail cone, basically right there at the joint. And then we want to have a connector there. So like 2 servo connectors. It doesn't need to be anything like super permanent or anything, because those connectors are going to be there just in case these tail cones need to come off, right? So that's the purpose of them. So we're going to get those done up, and then we need to add some extensions probably on these wires because they're not going to be long enough. But what I foresee us doing is probably running the afterburner controller. We really don't need to go that far forward. We could actually run it right in this area between the turbines right here. That's a great spot for them as well. So yeah, maybe that's what we'll plan on doing. So we can just pop these guys off. They actually come on and off now really nicely. So that's basically it. And we'll just keep them oriented on the bench in this fashion so you know which one's left and right. All right, guys, it's been 24 hours with these first tanks, and I can see that there's still pressure in them, but I'll show you. Usually when you undo the clips here, the Tygon will be stuck together. There we go, released. And this side, perfect. So that was awesome. These tanks held pressure for 24 hours, which is amazing. That's perfect. That's exactly what we're looking for. So these ones are good to go. We're gonna switch the fittings over to our saddle tanks and do the same thing. And there's one of our Afterburner lights set up. So the extensions, because of the way the lights are positioned, are a little bit different length. So that side used a little bit more wire than this side. So I brought them the pathway that I wanted. Here's the top right here. Brought them to the pathway that I wanted, cut them, put ends on them, took the other wires that are going to go to the controller and evened those guys out by lining the ends up, checking the wire, and then one of the wires had to cut that much off. So last thing I want to do here is take some shoe goo or goop or whatever you have and put that on the edge of the tape. Now this tape is great, but it does not stay in place permanently. So this is one of those little things that you want to do, and this make sure that that foil tape, which protects the wires, doesn't come up. Obviously it'll come off if you really want it to. You can just peel it up, but the little layer of shoe goop just helps keep everything down and in place. I'm not a fan of using stuff like silicone because the silicone doesn't really stick to the foil tape, doesn't really stick to the fiberglass, so it's not really a great bond. I prefer to use something that sticks quite a bit better, like this. All right, so now this light's ready to go. We'll do the same thing to our right side. All right, guys, we got our new Flyright stand that showed up, and we are ready to put the 15 on the stand. Ben at Flyright RC made a custom stand for us for the 15, and that is awesome. I'll show you guys some of the details here shortly. Just getting it fit on there. That's super cool. All right, so Ben at Flyright RC, he reached out to me and we designed this custom stand. Well, I gave him the dimensions. He did the design. I'm not gonna take any credit for it, but super cool. So we did a couple giveaways with the Flyright RC stands. This one is totally different. So first of all, it's hard to see on camera, but it's powder coated sparkly red. So thank you, Ben, for that. That is amazing. It looks so good in the light. We've got a double vertical and double cross members on this thing. So extremely strong and stable. Yeah, it makes everything just way more stable. The fold-up mechanism's awesome here too. So the base, the leg folds up like this, and then this whole assembly folds up that way. So it actually came in a pretty small box, essentially fully assembled right over there. So awesome. And then the creme de la creme, of course, he put my logo on that. So thank you, Ben from Flyright RC. Very nice shop stand, very nice field stand, very nice workshop stand, lockable casters. That is wicked. So perfect fit for the F15. That's wicked. This back support here is very wide because the 15 is so wide, but he also made it out of a little bit thicker material as well too, so it has more support to it. Maybe I can show you here. So yeah, that looks like, if I had to guess, maybe 1/4 inch aluminum, something like that. So that is cool. Very nice. All right, so both of our Afterburner lights are set up and curing, so we're just leaving those alone. And moving on to our engine mounting. Now I put the engines and pipes in here previously, and the reason for that was to check the alignment and spacing. So with the pipe sitting in here, engine mounted on the existing engine mounts, everything up and down, like this way, lines up perfectly. That's key number one. Now the reason that that's key number one, or step number one, is if the engine is sitting too low in the pipe and we need to make wider engine mounts, that gives us the opportunity to use G10 plates to make wider engine mounts, which we've done on previous projects. But in this case, with the engine mounted, pipe mounted, everything lines up perfectly. So we don't have the option to raise the engine up. So when we put the Chicoy 240 engine in here, those black marks are pretty much where the screw holes are. So they are going to mount in the existing engine mounts, but we're really close to the edge. So I want to add some reinforcement here. So we don't need much. So this is the system I came up with. So didn't have the right thickness of plywood. I think it's like 5.6 or 5.56 millimeters. So I had 2 thin sheets. I glued those together and then made these little strips like this. So these little strips are what gets mounted to the side of the engine rails. Now, in order to get this set up and glued nicely and everything, I'm going one step further, and I made these little tabs to make these setups right here. So this is that same rail extension with a little tab glued on the bottom. So this is sort of acting as our clamp as the plan here. So what we're going to do is we're going to put high sol on this joint right here between the rail extension and the engine rail. We'll put CA on this guy, spray a little bit of kicker, and boom, glue that in place just like that. So when that rail cures, it's going to be nice and solid, and then we can drill into this and not worry about pulling through or coming off the side of our engine rail. And then those little tabs on the bottom, they can just stay in place. They're not going to hurt anything being down there, and that's the final result right there. So this is the plan. That's what we're going to do. So I'm going to make 4 of these guys and get them glued in place. Okay, so we got our rail extensions installed. When I put this in, there was a decent amount of high sol that popped up. I just took my gloved finger and smoothed it all out, so it's nice and solid now. So we're gonna let those cure. Probably one of the most challenging parts of this aircraft, I think, for access is going to be, I don't even know if I can show you guys on camera, is gonna be our flap servo. There we go, which mounts right there. So it's definitely a bit of a challenge to get to. The actual opening is right here. The arm is quite simple. So this just sticks out of the fuselage like that. And there is a nice, well-fitting aluminum arm on the inside of the fuselage. So this is actually a really nice setup, very accurate. It's going to be very strong setup, clevis to clevis. The servos, as far as position goes, the output shaft goes towards the rear part of the fuselage. So the servo is sitting there like this. So this is going to be flaps off like that. So we're going to go 90, 90, 90. Everything's going to be at 90-degree angles. Takeoff flaps like this, landing flaps like that. So it's should be a very simple setup. And I think because of the geometry, because you don't have a mechanical lock, it's definitely a good idea to have a nice strong servo on your flap servo, like the 599 here from MKS. Great servo, but that's how the flap setup works. All right, guys, so it's time to get the flap servos set up. So this is how I would generally set up the flap servos. Always want to do it in tandem and want to make sure they're moving the right direction and the right amounts and everything. Now, on this setup, because we're not doing a mechanical lock, we're basically, our initial flaps off is going to be perfectly at 90. That's the match on this setup. So let's go through how we do this. So this is going to be our left flap servo. This is going to be our right flap servo. They sit in the plane like this, and the arm goes down like that. Okay, so we will turn our system on here first. We can see that our flap is on 8 and 9. And flap switch is that guy. Perfect. So what I'm going to do is I'm going to plug flap 8 and 9. So 8 is, of course, our left flap, which is this guy. So we're going to plug that one in. And 9 is our right flap, so we're going to plug that one in. Okay, so let's just pop these servo arms kind of roughly on there and see what's happening. So flaps are off right now. And we're going the wrong direction. So what I'm going to do is I'm going to go into our flat menu. So that's fine tuning. Butterfly flat menu. And when we use the flat menu, we're using Logmax for our flaps, and that is tied to our flight modes. So we're going to go into flap adjustment, and these are adjusting symmetrically right now. So we'll just go like this. And we'll go to takeoff flaps. We'll go to flaps off. So in order to give us the most amount of travel, what I'm going to do is go to roughly 90. I'm just picking a number. We're going to go here. We'll go there. And now, when we go to takeoff flaps and full flaps, you can see how much travel we have available, which is tons of travel. So we're going to go here for our flaps off, 90 degrees. Takeoff flaps, we want to be way less than that, so we'll just go all the way to here. But you want to get these limits set up so it gives you the most amount of travel. If we didn't adjust that flap off condition, what would happen is we wouldn't have as much travel as we do have available to us. So full flaps, obviously way too much. So we'll just go to a number like that. So the number doesn't really matter, but we're 90%, 61%, 26%. We've got tons of movement available still. So that's what we're doing for our flaps. I think this should work good. So the way this is going to be set up is basically like this. Actually, it's the other side, but it doesn't really matter. Maybe we'll go like that. So it's going to be set up like this. So when we go to full flaps, that's going to be like that. So tons of movement on that flap arm. I don't think we're going to need any more than that, but if we do, we still have lots available based on the way this clevis is going to sit on there. So we could actually, you know, if that clevis is on there, we could go tons more all the way to that point. So that should be just fine. So that's very simple setup. So now what we'll do is we'll go to flaps off and we'll just confirm that we are at 90, which we are. Really close to it and really close to it. So that is good. So now what we'll do is I'm going to get our servo arm bolted in place because that can be permanently fastened now. So we'll put our pinch bolts on there, our face bolt, and of course Loctite everything. All right, already loving this Flyright stand, not having the hood stand in the way because the hood stand was wider than the fuselage. So when you're standing here, you're butting up against the fuselage and the hood stand, and it's just on something wide like this, it makes a big difference. So that thing is awesome. Already loving it. Okay, so got our servos installed for the flaps. I'll try and show you guys. There we go. So not going to hook up the linkage until we get into the wings because we want to be able to plug the servo in, get it centered, get our wing installed, our linkage for our wing and everything. So as far as flap servos go, this flap servo is going to be as is until we move on to the wing portion. So the important thing was getting the wires run. And what we're going to do with all of our wires in the back now is we're going to get them all sheeted in snakeskin. But that is a great place to stop video number 3 in the Skymaster F15 XXL build series. And if you're offended by me calling it a build series, well, we'll call it an assembly series as well too. Maybe that makes you feel better. So We're making some wicked progress on this thing. All of the challenges we've had so far haven't been astronomical, so it's been a good project so far. Want to give 2 shout outs. Number 1 to Flyright RC. Thank you for sending the stand for the F15 XXL. Loving this thing already. You guys will get to see it throughout the rest of this build series and of course in future videos. And also want to give a shout out to channel members. Thank you, channel members, for watching the videos. Thank you for being a channel member. And if you're watching this and you're not a channel member and you're wondering what that is, there is some links down below to channel membership. It is a paid thing, and basically, in a nutshell, channel members get early access to all of our videos. So as of today, there's actually 2.5 weeks of videos already uploaded to YouTube that channel members have access to before they're released to everybody else on the regular schedule. So that's what channel membership is, and thank you, channel members, for doing what you do. Thank you guys so much for watching the videos. Thank you for supporting the channel. Looking forward to video 4, where we're going to continue moving forward. Thank you for watching, and we'll see you in the next video. I'm very excited to see everybody at Turbines and Tumbleweeds in Sweetwater, Texas, October 2nd to October 5th, 2025. See you there.